Hello everyone, I'm Tyler, and today we will be going over the Calculus BC 2009 FRQ question number 4. This is a non-calculator problem. This problem uses both AB and BC concepts. Looking at part A, we see that we're making use of Euler's method, which we learned in the beginning of BC. Second, for part B, we make use of Taylor polynomials, which was one of the ending points in BC. And for part C, we go back to AB, and we're asked to find the particular solution y equals f of x, given this differential equation with the initial condition. Going back to part A, we're asked to use Euler's method with two steps of equal size, starting at x equals -1 to approximate f of 0. So this part is 2 points, and they're asking 1 point for the correct use of Euler's method with 2 steps and the correct answer. So before we start the problem, I want to begin by defining Euler's method, and we can do this by setting f of n is approximately equal to the function of n minus the step size plus the slope, which is dy over dx, times change of x. So in order to approximate f of 0, we need to use 2 steps of Euler's method. So the first step would be evaluating f at -1/2. So in order to do that, we use f of -1 plus the slope 6x squared minus x squared y times change in x, which will be 1/2. In evaluating this, we end up getting 2 plus 2, which is equal to 4. So this is our y value when we approximate x at -1/2. Since we found f of -1/2 to be equal to 4, we can use that in our next approximation to approximate f of 0, where we use f of -1/2 plus the slope using the points from above times change in x, which is still 1/2. When we evaluate this, we get 4 plus 6 times 1/4 minus 1 times 1/2, which is essentially 4 plus 1/4, which is equal to our final answer, 17/4. So part A in question 4 isn't all that bad. All you're asked to do is use Euler's method, which is basically just plugging in values to get a final answer. So this part A is a gimme. Moving on to part B though, things get slightly more tricky. We're given that the value of the second derivative is equal to -12, and we're asked to find a second degree Taylor polynomial for f about the point x equals -1. The reason why this part B might be a little more tricky is because we are only given 1 point for a correct answer, and obtaining the correct answer actually requires quite a bit of work. So before tackling this problem, I want to go over the structure of a Taylor polynomial. So in this question, we're asked to find the second degree Taylor polynomial, so we will essentially have 3 terms. So the first term will just be f of x, second term will be f prime of x initial times x minus x initial, then the third term will be the second derivative of x initial times x minus x initial squared over 2 factorial, which is basically 2. So we can take advantage of this structure in order to find the second degree Taylor polynomial. The first thing we want to do is find f of x at x equals -1, and that's given to us in the problem of f of -1 is equal to 2. So the second part we need to find is f prime at x when x is equal to -1. In order to do this, we just plug it into our differential equation, and we end up getting 6 times 1 squared minus 1 times 2, which is just equal to 4. The third part we want to do is find the second derivative, f double prime of -1, and this is given to us in part B as -12. So now we can use our found values and plug them into our Taylor polynomial structure in order to get our final answer. So we end up getting 2 plus 4 times x minus our -1 plus -12 times x minus our -1 all squared over 2 factorial. So simplifying that, we get 2 plus 4 times x plus 1 minus 6 times x plus 1 squared. So looking back at part B, The only reason what makes it tricky is because it's asking for a lot of work and you're only given 1 point for the final answer. So I think a good strategy when attacking these problems is definitely writing out the structure, because that will help you a lot just understanding the whole premise of the problem. So moving on to part C, we're asked to find the particular solution y equals f of x to the given differential equation with our initial condition f of -1 is equal to 2. For part C, this is basically where all the meat of the points goes. So even if you don't know how to do part A or part B, doing this step correctly gives you 6 out of the 9 points, which is a lot. So before I go over the answers to part C, I want to review the scoring guidelines, as this is a very meaty problem and it's important to understand where you can get points. So first off, the easiest point to get, separation of variables. Then you get 2 points for using the correct antiderivatives of y and x. Then the next point, another easy point, is the constant of integration, where we're going to add part C to the x side of the equation. Then the next point, we want to use the initial condition, and this is when we use the initial condition after solving for C. And then finally, the last point is when we solve for y. So beginning this problem, we want to obviously set up the differential equation dy over dx is equal to 6x squared minus x squared y. We then want to factor out the x squared, so we get x squared times 6 minus y. And then when we separate our variables, we will end up getting 1 over 6 minus y dy equal to x squared dx. And this is where we get our first point. So the second step will be to antiderive both y and x. And let's do the easier side first, x squared. Obviously, that antiderives to 1/3 x cubed. And then we want to make sure we add the constant plus c to the x side. And then going back to the left side, I'm going to use a u substitution inside my head. And we get negative ln, absolute value 6 minus y. It's important to remember to add the negative in front of the ln, because when we do a u substitution, du will be equal to -1. So at this point, we're ready to solve for c. So we want to use our initial condition, f of -1 is equal to 2, and plug that into our equation as it looks now. So we will end up getting negative ln 4 is equal to -1/3 plus c. And by just using simple algebra, we get that c is equal to 1/3 negative ln 4. After finding this value, we can then plug in c to our initial condition from above. And by making use of a little trick where you cancel the natural logs, we will end up getting the absolute value of 6 minus y is equal to e to the power of -1/3 x cubed minus 1/3 plus ln 4. So our last step will be to solve for y, and in doing so, making sure we keep track of all the negatives, we will get y equals 6 minus e to the -1/3 x cubed minus 1/3 plus ln 4 power. And this answer is okay for College Board, but if you want to simplify that down further, here is the simplified answer, y equals 6 minus 4e to the -1/3 times x cubed plus 1. So that's it for question 4 on the 2009 Calculus BC exam. I hope this video helped you guys understand this problem, and I hope you guys all have a great day. Thanks.